Hello everyone, and thanks for watching Edupedia World Videos. This is the first video in the course for 12th class mathematics, and we'll begin with our study of matrices. Now a matrix, the formal definition of a matrix is that it is a rectangular array of numbers. It can be a rectangular array of other things as well, functions for example, but for our course we'll only take numbers. Now an array is basically a fancy word for saying a collection. So it is, we'll get to rectangular later. It is basically, a matrix is a collection of many numbers, right? So before getting into the details, I'll just give you one small example of how this can be useful. Let's say you wanted to plot the equation y is equal to 2x plus 3 on the coordinate axis, and you wanted to plot it between x is equal to 1 and x is equal to 100 at integer values of x, 2, 3 and so on. So you would have 100 different values of x. For each value of x, you would need to apply this equation, get the value of y, and then you would plot the point x comma y, and you'll get not exactly a curve but a set of 100 points which would look like a curve, and those points will give you the value of y is equal to 2x plus 3 at 100 different points. Now it's much easier to do these sorts of computations on a computer using many different softwares which are available, and most often the softwares use these arrays or collections of numbers. So in that software, what I would do is, instead of taking 100 values of x and applying this equation 100 different times, I would take an array of x. An array would be denoted by a capital letter, and it would be a collection of 100 different values of x. It would, let's say, be represented like this, between square brackets, 1, 2, 3, and it will go on to 100. So it will be a big rectangle, 2 square brackets, which include 100 separate values, and x would be a collection of all of these values. Once I have established that x is an array which includes the integers between 1 and 100, I could simply input the equation y is equal to 2x plus 3 into that software, and it would automatically give me y as an array of 100 numbers, where each number would have the value of 2x plus 3, with x being the corresponding initial number. So the first one, it will be 2 plus 3 5, then it will be 4 plus 3 7, then it will be 6 plus 3 9, and so on until whatever the last value is. So instead of writing this equation or telling the software to calculate this equation 100 times, which it does anyway, we just have one array and we apply the equation one time, and the computer can take care of a collection of numbers. So this is one of the many applications we have in which we take a whole collection of numbers as a single entity, which is an array of numbers. Right. Now a matrix is a special type of array. It is a rectangular array, which just means that the numbers are there in a rectangle. They can be more complicated forms, but for you a rectangular array is sufficient. So this is a single row vector. We'll get into that in a minute, but this is a single row vector because this includes numbers on one line only. But you can have arrays like z is equal to 1 3 2 4 5 9 0 minus 2 6. This would be an array of numbers in which the 9 numbers are not all in the same line. They are separated in 3 different lines, and this would have different significances. These numbers are of course in a rectangle as opposed to these numbers which are in a straight line. Another example in which you could see why these forms of matrices are really useful is, let's say you own 3 factories. We'll just call them factory 1, 2 and 3. You own 3 factories. Let's say all 3 of those factories make 2 things. Let's say they make shoes and socks, and you wanted to know how many shoes and how many socks each factory made. So you could store that in a rectangular array of numbers, which would be, let's say, 5 and 2, 7 and 1, 6 and 4. You could say each of these represents 1,000 units or whatever, or you could say it's 1 unit. For the case of simplicity, we'll take that. So the first factory made 5 shoes and 2 socks. The second factory made 7 shoes and 1 pair of socks. The third factory made 6 shoes and 4 socks. right? So instead of having 6 different values of representing, let's say, x, y, z, a, b, c, x is equal to 5, y is equal to 2, z is equal to 7, and so on, instead of having 6 separate variables, you could have just one variable, call it, let's say, a. And A would be an array of 6 numbers arranged in such a way that each number would tell you how many of a particular item were made at a particular factory. Now note where the number is has significance here. If I took another array B, a similar array which would have the numbers shuffled around 2, 5, 7, 1, 6, 4, then these two would mean very different things, right? In the second and third factory it would be the same, but in the first factory, the first one says you have 5 shoes and 2 socks, the other one says you have 2 shoes and 5 socks. So we see that the position of a number is also important after you've decided what the matrix stands for. Now I'm going to start using the word matrix instead of array, because like we said, matrix is a rectangular array of numbers, and that's all we'll be concerned with right now. So you could say that an array represents, or a matrix represents, in the row line it would represent the item made, and in the column line it would represent which factory. Now if you have, let's say, 12 different matrices like this, each and every one of them representing the quantity made by a factory in a particular month, then you could add all 12 of those matrices and you could end up getting the matrix for the whole year. How do you add 2 matrices? We'll discuss that in the next video. So hopefully by now you've seen the importance of taking numbers together in a group or in a collection as opposed to individually. It reduces the amount of work we have to do. For example, a single array, it still holds the same amount of information, remember that. You could have 6 numbers, or you could have a matrix which is a collection of those 6 numbers. Just computationally and in terms of writing equations, it's easier. It's easier to write A is equal to this, B is equal to this, than writing the number of shoes in 1 is this, the number of socks in factory 3 is this, and so on. Right. So let's now get down to the proper definitions of matrices. A matrix is composed of rows and columns. So we just take a general matrix right now. 1, 2, 4, 7, minus 2, 3, 5, 9, 2, 7, 8, 0. Now remember, it cannot be that there are 4 entries in the first 2 lines but only 3 entries in the third line, because then it would not be a rectangular array, right? A rectangular array has to have the same number of entries in each row or each column. Right, so we are only discussing matrices which are rectangular arrays. So these lines, the horizontal lines, are called the rows. So for example, this would be the first row. The first row of the matrix. This would be the second row. This is the third row. Similarly, the vertical lines are called columns. So this is the first column. I'll not write it for the others. So if you ask somebody what was the entry in the second row, third column, you would say, look at the second row, this is the second row, the third column, you would say that it was 5. So now we see where a number is placed has importance as well in matrices. So you could have any row and any column, and the total number of rows and columns tell us what type of matrix this is. So let's say this matrix is represented by the capital letter A, then we would say that A is a 3 cross 4 matrix. Matrices are referred to as an M cross N matrix if it has M rows and N columns. So this particular matrix is a 3 cross 4 matrix because it has 3 rows and 4 columns, and of course an M cross N matrix will have a total of M into N entries. Entries are what go into the matrix. 3 would be an entry, 5 would be an entry, and this one has a total of 12 entries. So this is a standard rectangular matrix which is referred to as an M cross N matrix, which means it has a total of M rows and N columns. They both have to be integers, and of course any entry could be in any row below that. A 3 cross 4 matrix could have an entry in the second row and third column, right? Don't confuse those two. A 3 cross 4 matrix has a total of 3 rows, which means it has a first row, a second row, and a third row. Now we represent entries in a matrix as Aij. So just like we represent the matrix by a capital A, we represent the entries in the matrix by Aij, where I refers to the row and J refers to the column. Right, just remember this, that row always comes first. Now what will I be? I will always be either 1 or it will be M, and J will always be either 1 or N. Right, so Aij refers to the ith row and the jth column. So saying that the element or the entry in the second row and third column is 5 is basically equivalent to saying A23 is equal to 5. What is A31? Third row, first column, that is 2. And we see that the value of the column would be either 1, 2 or 3. Right, 1 less than I less than equal to M. M is the total number of rows. Right, sorry, the row would be between 1, 2 and 3, and M is the total number of rows. The column, here is 3 and here is 1, will always be 1, 2, 3 or 4. Right, so it will be less than equal to 4. 4 is N, the number of columns in this case. So just a small recap. An M cross N matrix has M rows and N columns. And by the way, we'll in this course only be talking about real numbers. Actually, matrices can have complex numbers as well, but that's not in your course right now. So for us, it will always be real numbers. Right. So it means the entries will be like A11, first row, first column, A12, first row, second column, and so on, A21, and so on until it goes to AM1 here, A1n here, and AMN here. So Aij means the entry in the ith row and jth column. There are a total of m rows and n columns in a rectangular matrix, and obviously we'll always consider Aij to be real. Now let's look at different types of matrices that are in use. There are some matrices which would be called row or sometimes column vectors. Now you all know what vectors are. You've done them in physics in 11th, and here vectors are used in a slightly different context, but the maths will always be the same, right? So a vector is basically a matrix which has either only one row or one column. If it is, let's say, a matrix which has only one row, then it is called a row vector. An example would be 1, 2, 5, 9. If a matrix has only one column, then it is called a column vector. An example would be 1, 2, 5, 9, like this. Right. They're also sometimes called row matrices and column matrices, but the more commonly used terminology is row and column vectors. So a column vector would be simply a matrix having only one column, and a row vector would be simply a matrix having just one row. Then you have another type of matrix which is called a square matrix. This will be the most commonly used matrix for you in this course, and a square matrix is basically an M cross N matrix such that M is equal to N. So if a matrix has 3 rows, 1, 3, 5, then it should have 3 columns as well. And this will be a 3 cross 3 square matrix. So a square matrix, as the name suggests, is a matrix that is not just rectangular but it is square. That means the number of rows and the number of columns is the same. Then you have the next type of matrix, which is a diagonal matrix. So let's take a 3 cross 3 matrix. Now a diagonal is part of a square matrix, right? So all the types of matrices we'll do now are subsets of a square matrix. So it will be 1, 0, 0, 0, 2, 0, 0, 0, 5. These three elements, these three entries, or any entry of the form of AII, that is the row and the column number are the same, will be on the diagonal. This diagonal is called, the diagonal going from this side to this side, not the other one, is called the main diagonal. This is true for any matrix. For any matrix, this diagonal A11, A22, A33 and so on is called a main diagonal. Of course, it will only be a diagonal for a square matrix, otherwise it would go something like this. And then these terms would not be taken care of. So a diagonal matrix is a subset of a square matrix in which only the entries on the diagonal are non-zero. Every entry that is not on the diagonal is 0. So Aij is equal to 0 unless I is equal to j. So these entries are 0, these entries are 0. This is called a diagonal matrix. Now there are other matrices which are not exactly diagonal matrices but derivatives of that. You have an upper diagonal matrix. Or sometimes it is also called an upper triangular matrix. And that matrix is a matrix which has all the elements below the diagonal 0. So the elements are sort of in a they are on the diagonal and they are on the upper triangle of the diagonal. So it will be like 1, 3, 5, 9, 4, 0. I'm sorry, I got the order a little bit wrong here. 1, 4, 7, 5, 3, 6, 9, 4, 2 and 5, and this will be 0, 0, 0, 0, 0, 0. So entries on the diagonal and on the upper side of the diagonal. This is called an upper triangular matrix. Similarly, you could have a lower triangular matrix or a lower diagonal matrix. And that, you guessed it, is of the form of, let's just take 3 rows and 3 columns now. 1, 2, 4, 6, 7, 9, 0, 0, 0. So this would be a lower triangular matrix. Next you have a scalar matrix. A scalar matrix is a subset of a diagonal matrix. All these definitions will be very natural to you soon when we start actually doing operations on the matrix. Right now it's just good to remember the names of different types of matrices. So a scalar matrix is a diagonal matrix with all entries equal. So let's say a matrix like 7, 0, 0, 0, 7, 0, 0, 0, 7. Not only is it a diagonal matrix, but all the entries on the diagonal are equal. They have a value of 7. So we'll say this matrix, let's say capital A, is a scalar matrix that has a value 7. Now just one small thing. After doing matrices, we'll move on to something which will be a little bit different from matrices but really similar, and that will be determinants. And determinants have a value. They can be evaluated. A matrix does not have a value. You cannot generally say a 3 cross 4 matrix has a value equal to 15. Right? A matrix is a set of numbers. It does not have its own particular value. Right, so we say that it is a scalar matrix with value equal to 7, but it is still a collection of 9 numbers, 3 of which are 7 and 6 of which are 0. So this is a scalar matrix. And finally you have the identity matrix. An identity matrix is just a scalar matrix with value 1. So it is a matrix of the form. Now remember, the number of rows and columns is not fixed. It could be a 3 cross 3 or a 4 cross 4 or a 7 cross 7 matrix. I'll just make it for a 4 cross 4 matrix. It will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. Right. And this matrix is generally referred to by the capital letter I. And this is a very useful matrix because after we've done how to multiply two matrices with each other, we'll do that in the video after the next one. After that, we'll see that multiplying a matrix by I is basically sort of like multiplying a number by 1. And that's why it is called the identity matrix. It plays the value that 1 plays in numbers. It plays that value, it plays that role when you talk about operations in matrices. So this completes this video. In the next video, we'll start looking at different operations on matrices, such as when two matrices might be equal, how do you add two matrices, how do you multiply a matrix by a number, and so on. Thank you.